Boom. So what's a load balancer? Last week we talked about load balancer. What's a load balancer? Anybody want to define load balancer in your own words, right? What's a load balancer in your own words?
A load balancer is it helps to distribute traffic to servers.
Mhm. That's correct. Anybody else? Give it a try.
Like we say, a load balancer is a device that receives traffic and share that across the servers.
Okay.
I would say load balancer is a component in the cloud that helps to distribute traffic across multiple servers.
Yeah. All of those answers are correct, right? They're all correct. So load balancer enables you to achieve increased levels of fault tolerance. You won't hear this word every day in the industry or on the job, but fault tolerance is pretty much what something that just says it can sustain faults, right? If one server goes down, another server can be available to handle the application. So that's fault tolerant. Your application is fault tolerant because you have auto scaling enabled, you have a load balancer behind the application. When I say behind the application, this is what I mean, right? Right. The load balance, this is the front end, this is the load balancer here. So you have a load balancer. This is your domain name. This is you just connecting via your domain name. This is load balancer. So you have application behind your load balancer, right? So it's fault tolerant by seamlessly providing required amount of load balancing capacity to distribute traffic, application traffic. What is that traffic? The request. When you make a request to geico.com, the load balancer sends your traffic to a specific server. You create your account, you do those things. Next time when you come, because you were on that server one, it might send you again to that same server to improve your experience, right? So that's what the load balancer really is. Simple as that. Load balancer provides high availability. Why? Because incoming traffic across your EC2 instance in a single zone can go down, right? If you have one AZ, so one availability zone is what? In US is one, you have six availability zones. US is one A, B, C, D, E, F. If you have just one availability zone and you have the application running on an EC2 instance in that one zone, if that zone goes down, your business goes down. But with load balancing, you have high availability. You can have four EC2 instances in US is one A, and you have four EC2 instances in US is one B. If US one goes down because of a tornado in Virginia or something like that, US one A, right? If US one B goes down, US one A can continue serving the application and business continues. So this is part of high availability, disaster recovery, business continuity. Business must continue. Because when you open up a company is defined as an ongoing concern. A company is an ongoing business, an ongoing concern. A company must always continue to run regardless of whatever is happening. Okay, that's the definition of a business. It's always going to run. So that's why when you have a business and it's running in the cloud, you want to have high availability. You want to be able to make sure it's running nonstop, right? And yeah, that's that. Okay. So pretty much load balancing gives you that high availability capacity to have multiple availability zones. You can have up to six, right? One, two, three, four, five, six, right? It's just depending on your application requirements, your high availability requirements, and those things. So now, how do you detect that a server is down? How do you know that a server is down? The load balancer is in charge of that, right? The load balancer can detect health healthy instances and unhealthy instances, we're going to create a check that was going to be pinging the load balancer. What happens is, sorry, the EC2 instance, the load balancer sends a ping, a simple ping like this, like a ping, right? Like a ping www.google.com, like that. That's a simple ping, right? The load balancer can send a ping to that EC2 instance every 5 seconds. Oh, what am I going to? Every 5 seconds, or every 3 seconds, or every 1 second. If the self EC2 instance responds back to it, it means it's healthy. If it doesn't respond back, then it means it's unhealthy. That's how the load balancer is able to keep the EC2 instance in constant communication. Like, hey man, I'm gonna be giving you work at any given time. So I need to make sure that you're responsive. So if I check on you, ping, hey, are you there? Are you there? Are you there? If I check on you 3 times and you don't respond, I'm going to mark you unhealthy and not give you any more requests. If I check on you 1 time and you respond, I'm here, you're healthy. If I check on you second time, you respond, you're healthy. If I check on you third time and you don't respond, I'll wait 5 seconds, I'll check again. If you don't respond, I'll wait five, I'll check again, you don't respond, then it means you're unhealthy. I'm going to mark you unhealthy. Once I mark you unhealthy, there's number of instances here will go down. And because if it's below the minimum, which is supposed to be 3 instances, auto scaling kicks in and launch one new instance to join the group. And then I have to drain out all the connections that were on here, all the requests that were on here, drain them out and reroute them to the new server that's going to join here. That's why the health checks are so important, right? When you detect an unhealthy instance, it will spread load across the remaining instances and no longer route traffic to the unhealthy instance. Without health checks, you cannot run a fault-tolerant application. Okay? So we'll talk about 3 things already. Load balancing, high availability, health checks. Security features. Load balancers create and manage security groups associated with it to provide additional networking and security options. So a load balancer has its own security group. This is just the load balancer. Why? Because all traffic connects to the load balancer. We want to put it in a separate security group and allow HTTP and HTTPS traffic coming from the internet to hit that load balancer, right? We don't want customers hitting our EC2 instances directly. No, 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 no. That's not best practice. So the load balancer is here and this layer. The web servers are here, applications are here, databases are here. So each of these ones have their own security group. This load balancer has its own security group that allows traffic from the internet, HTTP and HTTPS. Then this web server here has its own security group that only allows traffic from the load balancer security group. You see that? So that's how we're securing it. No, nothing else can connect to these web servers. Only the load balancer can connect to these web servers. So it makes our web server secure. And then similarly, the application server that is going to be here, only the web servers can connect to the application servers. So that's how we trickle down this. If I was going to go to the board and show you, let me go to the whiteboard. Start that way. Thing is slow today. So here is your load balancer. Let me use an actual load balancer icon. Let's do the AWS one. Okay. So let me start using real icons to you so that when you get on a job, you're used to it, right? You're not surprised because you're gonna see this icon again on the job, I guarantee you. Security group. The AWS one, it's right here, right? Right. And this security group, you guessed it, is what? Within a subnet, right? Load balancers are always what? If it's a public subnet, right? If it's it's a internet facing subnet, it'll be what? In a public subnet, right? This is how your 3-tier application will look like, right? So this is your load balancer layer, right? And then you also have a similar layer here. Let me reduce this a little bit, space. That's fine. Here you have EC2. EC2 instance, right? But here you have a public subnet, but you have two of them, right? So load balancer spreads traffic to this guy, and load balancer spreads traffic as well to this guy, right? This is your web layer, right? And then you have a private subnet. Guys, at the end of this class, I'll be expecting you guys to be able to explain this 3-tier architecture. Most interviews ask about it. I can do a write-up for you guys to be able to explain it. But you need to be able to explain this, okay? It's very, very important. And then boom, you have another something like that. So this is what? This is US-East-1A and US-East-1B, right? And then guess what? You can have a load balancer here, which is gonna be what? Since it's internal, it'll be what? In its own private subnet. Oh, not even like right there. Architecting takes time, not because you don't know what to draw, but just, trying to make it look pretty. And then security groups, of course, which is what we're talking about, sits in those places. Got boom, like that, boom. And then this load balancer here receives traffic from these EC2 instances. When you want to click order, place my order, or click pay, receives traffic from them, and spreads the traffic from them now to this application EC2 instance. And this is your application layer. right? So how many security groups do you have so far? 1, 2, 3, 4, 5 security groups. How many subnets do you have so far? 1, 2, 3, 4, 5, 6 subnets so far. Yes? 1, 2, 3, 4, 5. Actually, you're supposed to have 6 security groups as well, because this load balancer has its own security group, right? This load balancer has its own security group right here. Like that. Boom. Right? So that's the layer. What's the last layer? What's the final layer that was missing here on this diagram? What's the final layer that's missing? Yes, exactly. The data layer, the database. All right. And what is that going to be in? You guessed it, private subnet. There is no load balancer going to the data layer, right? Database does not need load balancer. What database is there for AWS? It's RDS database. Okay. All right. So this is your primary. And this is your standby. Tolu, I feel like you're watching TV. Are you here? Are you watching this or you're watching TV? Tolu, are you
I'm
here?
here. Yes, I am.
I think you just told me you're watching TV. I don't know why.
Oh.
Yeah. So somebody just said, "Oh, is that true?" Yeah. I have a full eye. Boom. And guess what? All the traffic from these application servers, right? This is the application servers, right? Java application running here. This is your web server layer. These application servers send their traffic directly to the database. This one sends directly to this database as well, right? And then this database replicates to this database. Sorry. Oops. This is a master, this is a slave. Again, we don't use that terminology nowadays since 2020, but this primary is standby. That's what we use. We don't use master slave, right? Because the master sends work to the slave or sends stuff to the slave to save it, right? So in case one day, this is your high availability fault-tolerant architecture. This is how it looks. One day, if US East 1A goes down, the whole algorithm will go down. What goes down? This is going to go down. This is going to go down. This is going to go down. So what happens? All the requests will continue coming to the load balancer. Load balancer will send it to US1B. US1B will continue processing the request and send it to the load balancer. This load balancer, it exists in both AZs, both at the V zone. So it's in US1B, it's also in US1A. It's more, is right. And then so it will send traffic now to US1B, and this standby database will switch over and become the primary. So traffic will move, instead of going to here, the request will now come to here. So this is your database layer. Okay, interview question. What about objects? Where are your objects stored? Your image files for your website, where are they stored?
S3 bucket.
S3 bucket. So how do you connect that? Boom, you guessed it. S3 bucket. S3 is a public service. S3 is a public service. S3 does not exist in a subnet or none of that. S3 is a region-specific service. It doesn't have to be in a subnet. So you can have an S3 bucket out here, right? You can be in a data layer because it's a data thing. But the images that are stored here are serving the website over a private network, which is the AWS backend. It's called what? It's called S3 VPC endpoint. So instead of going over the internet, the traffic between your bucket and your web server is not going over the internet. It's going to the VPC back end of AWS. It's a private network. So you know how between your account and AWS, there's a private connection. That's how Amazon is able to manage your account. Okay. That's how Amazon is able to manage your account. So with that being said, the traffic goes from your bucket to the web server, right? In that manner. Okay. That's how it works. That's how it looks. That's how it works. Any questions so far? Any questions so far? Before I continue, ask me some questions, guys.
I have a question. I'm a little bit confused about the nomination, how you naming the different load balancer. Application load balancer at the top, application load balancer at the middle.
Yes. What is this load balancer called, guys? The one that is facing the internet.
Internet facing load balancer.
There you go. Isabel fashion dash dot fashion Isabel dash fashion.com. So, I don't understand your question. What do you mean naming convention? What do you mean? You name the load balancer according to where it belongs. This is internet facing load balancer because it's external. This is an external load balancer. And this is what? An internal load balancer. So what's your question?
Okay, no, the problem was that the first time you introduced load balancer in the past, I was thinking application load balancer was only for the private
No.
subnet. That's
Application
the way
load
I
balancer is
understand.
application. We use
Yeah,
application
so
balancer for the web server and also for the application. It doesn't mean because it's called application load balancer, you only have to use it for the application. No. Because applications have, in the past, right, we'll use the classic load balancer in the past. This would be called classic in the past. But nowadays, because we want to improve users' experience, right, we need to use application load balancers at every level. What does that mean? Let's talk about sticky sessions. Sticky session enables the support the ability to stick user sessions to a specific institution using cookies. Cookies is when you open up a new website, there's something that comes up in your browser, cookies. When you accept cookies, every time you go back to that site, they'll send you to the same web server. Traffic will route to the same instance as the user continues to access the application. That's what cookies is. So application load balancer, they are smart load balancers. They are smart. When you go to geico.com, right? If you go to geico.com, if you bought car insurance in the past and you accepted cookies, when you open this website, it will automatically take you to auto, right? Because it has ticked your session. It has created your session on geico.com/auto. So it's going to stick your session to auto, and then boom, start my code. It takes you there and start asking you extra question. So application load balancers are smarter than classic load balancers. Classic load balancers are layer 4 load balancers. All they do is transport traffic from the internet to the web servers. Application load balancers can know the request is auto insurance, can read the request header and say, oh, this is for Geico home insurance, and route your traffic to the correct server. And the user experience is better because I can come here and say, I can just come and Google Geico auto insurance, enter. And boom, it takes me to Geico auto insurance like that, automatically, boom. You see, auto insurance.org, that's it, boom. So the load balancer knows my request because it's able to read my request because there's auto involved here. It sends me to an auto server. You see that? Because some applications have auto web server, home insurance, boat insurance. So we now use that level an application load balancer because an application load balancer is an advanced server. It has advanced routing. You can look at your header and say, hey, this guy is asking for an advanced routing. I'm going to send it to this specific guy. Okay? That's what an elastic load balancer can do for you. Okay? Is that clear enough?
Yes.
Okay. Cool. Any other questions? Any other questions?
Yeah. Uh, the security group of VPC is different from the security group of application load balancer, right?
Yes. No. Costa, stop. Pause. Let me pause the recording. What you just said is completely. Actually, don't forget, this is a typical VPC. VPC is made up of VPC, subnets, and security group. Each subnet has its own security group. Right here. This subnet has its own security group. This one has security group. This one has its own security. This one has security group. You see that? So what happens when traffic comes from the internet? HTTPS and HTTP traffic, like you see here, this traffic HTTPS, it's only going to hit this load balancer. So if anyone is sending any kind of malware or bad things to us, whatever they're sending to us that's bad, it's only going to hit this load balancer. That's it. It's not going to hit anything else. And the load balancer is managed by AWS. So we are safe, we're protected. If we don't have load balancer and traffic comes and hit our HTTP instance, we're not safe because it can send me a virus and it hits our application and destroys it. So the load balancer receives all the shock. If the load balancer receives a virus, it will just destroy it. The load balancer only processes good requests, traffic, because it scans it and say, oh, this is a bad request. I'm going to throw it away. Load balancer always send good requests to your servers. So in the security group here, in the inbound rules here, in this security group, we're only allowing the security group ID from here to connect to him. So this load balancer doesn't have an IP address. No. This load balancer doesn't have an IP address because it's in multiple availability zones. It doesn't have an IP address. So when we put the load balancer in the security group, let's say the security group, the security group ID is, and this is very important because this is going to come in your interview, SG-345678. That's the security group ID. Okay? That's the security group ID. This is the load balancer security group. Right? Right here. External load balancer security group. And let me just remove this line actually and just put this right here. This is a security group ID. Since it doesn't have a load balance, it doesn't have an IP address, how do we allow connections from the load balancer to this security group? You guessed it. In this security group, this one, this security group has its own. This security group has its own. It has its own ID. The security group ID here is SG09876. What's that? It's 6 characters. 09876.5. That's 6 characters, right? So in this security group, in the inbound rules, we're going to allow this ID. We're going to allow this guy. in here. We're gonna allow SG dash 3, 3, 4, 5, 6, 7, 8. We're gonna allow connections from SG 3, 4, 5, 6, 7, 8. Because there's no specific IP address that a load balancer has, we're gonna just allow this security group to connect to our security group. So traffic from here connects to any EC2 instance in here, any EC2 instance in this group, in this sub-security group. And since we'll have auto-scaling and we'll have high availability, if we have 4, 5, 6, 7, 8, 90 instances in this security group, this traffic from here can connect to any instance in security group. If we use IP addresses, it will be an issue because IP addresses change when EC2 instances come up, go down, they change. But if we're dealing only with the security group IDs, we don't have that problem of IP addresses because we're dealing with the security group IDs. This is a senior cloud engineer interview question. Same thing down here. This EC2 instance needs to connect to the load balancer here and provide, and this load balancer collect requests from here. So what in this security group, what would you put in this security group to allow traffic? You guessed it. You're going to put this ID. You're going to allow this ID. Sorry, if this security group here, if its name is 1111111. In the inbound rules here, you're going to allow SG 098765. So this every traffic from this security group, you're not doing IP addresses. Because if you do IP addresses and a new instance comes up and that instance is not in this security group, the IP address is not in security for inbound, you have connection issues. But if you do the security group ID for this security group, SG09, and you allow all traffic from this security group, connect to your load balancer here, then traffic will flow through. And that's how you trickle down. Now, in this security group here, application layer security group, if this application security group here it's called SG, it's SG-222222. You want to allow inbound rules? What are you going to allow? Tell me what you're going to allow here. Somebody tell me what you're going to allow in this security group. If you want traffic to come from load balancer to this security group here, what are you going to allow here? SG what?
1-1.
1111. Isabel, correct?
Yes.
Yes, that's it. This is how we schedule networking and high availability because we don't want to deal with specific IP addresses. These things change. It's high availability, it's auto-scaling. This instance is going to shut down. And that instance will come up.
I have a question. What if we use elastic IP?
That's even elastic IP is better, Isabel. Perfect, correct, good job. Clap for Isabel. That is good. Elastic IPs would not change. But guess what? Elastic IPs are expensive. Oh. Guys, when you become an architect like me, you need to think about costs. I was yelled at today for leaving an EC2 instance running since Monday. They yelled at me. Debo, are you testing that? Are you testing that application or why is it up and running? And like, oh, I was going to test it till Friday. Well, can you just shut it down when you want to test it, turn it back on? It's been running since Monday and it's already at $300. I got that email today. You have to think about costs. No matter how much, if it's a $1 billion company, they have billions, but there's, the small things matter. It's not about the $300, it's just about the behavior. If you're someone that is careless, then, they don't want to deal with you. But I mean, Even me got yelled at. I'm like, damn. I was testing some application. I was doing a POC, a little demo to go and to help me create my diagrams, but they're like, yo, turn it off. Even when I was out of the country in December, I forgot one EC2 instance up and running. A T2 micro. I got an email, an escalation email that I left the T2 micro running. Are you serious? Like, are you gonna email me when I'm on vacation about a T2 micro instance? And I had to log in on my phone and respond to the email saying, hey, I'm not on my computer. I didn't bring my laptop with me in Ghana. Like, I'll have to shut it down when I get back to the US. Or someone can log in and shut it down on my behalf because I'm not going to be back in the country till this time. So, Isabel, great idea. Elastic IPs are perfect for this situation, but it's expensive. So the cheaper option is to go with, the default option, which is a dynamic IPs. But instead of using physical IPs in the security group, you provide the security group ID in the security group below, so traffic can flow from here to here to here to here. And you trickle it down. Same thing. If the security group here, oh, I forgot. Databases have security groups too. We forgot about that. That's why when you understand this particular architecture, my brothers and sisters, you will never lack a job in AWS. Because what you're seeing in my screen, yes, is the most difficult thing to understand and to explain in an interview. This question about explain to me a 3-tier architecture can take 1 hour, 30 minutes to explain in an interview. And if you can get it right, the networking pieces correctly right, you got that job. This is what Deloitte asked for their interview, by the way. I said some Deloitte jobs to do with you. This is what Deloitte asked in their interview. They don't ask anything else. The interview is a 45-minute interview. This is what they ask. You explain it from top to bottom. That I will have a load balancer in the web server layer. I will have a public subnet. I will have USS1A. You explain all these things to them. You have a load. You explain everything from top to bottom and how you schedule the RC bucket to serve the content, databases, and multi-AZ here. You explain all these things. Boom, you got the job. I'm not even joking, because this is not something that everyone understands, right? This is actually, they can go deeper. You can go deeper and deeper. Okay, what database are you running here? Are you running a Postgres, Oracle? What AMI are you using here? What is the size of your instance in your application? Are you using this M3, a C5? They can go deeper and deeper, right? How many requests is coming in, right? How do you make sure that users are able to get fast performance? What do you do? They can go deeper and deeper, but this is just the basic. Okay, this security group here now on the database side, right? Database side right here. This security group here is what? Let's say the ID for security group is what? Let's say it's the ID for that security group. SG security group is 444444. So traffic coming from here, from this security group to this security group, what are we going to allow? What are we allowing here in the inbound rules? Allow? Come on, guys. Tell me, What are we allowing here? Traffic coming from this security group here. Security group here. This one, traffic coming here. What are we allowing here? What are we going to allow? SG what?
111.
Nope.
222.
The twos, yeah.
Kwasi, wake up, Kwasi. Drink some tea. 22222. Right here. Application is connecting to database in this line. Yeah? Application is connecting to database. Okay? So you don't allow 222222. That's it. Is it clearer now? That's it. So you're gonna have how many security groups? 1, 2, 3, 4. Right? Or if you want to look at your whole architecture, you have 1, 2, 3, 4, 5, 6, 7, 8 security groups. That's it. And then this security group is there, but this is a standby. If something happens, this security group is only sending traffic to this security group. So in this security group here, this security group here, let's say the security group here is called SG-555555. Because this primary database is sending records to this standby database to store the records, what is this standby database security group? What is it going to allow? What is he going to allow in here? What's he going to allow? Don't look at what I'm copying. Just tell me what you know.
SG444.
Go ahead, Kwasi. What is he going to allow in here? Inbound rules. Allow. What's he going to allow in here? What security group is going to allow? Because he's sending traffic or sending records, right, to the standby database to store the records in here, so that in case he goes down, he becomes a primary, or in case he goes down, he becomes the master. This is the master. This is the slave. In case the master dies, the slave becomes the master, right? But we don't use that word anymore, right? Like I said, we now use the word primary. Primary means master. Standby means slave. So if primary goes down, standby becomes a primary and continues serving their application. So in this security group, what are we allowing? Because you need to allow traffic between the two, right? So that you can send records. So in here, what are we going to allow?
Oh, I think you allow S222.
Go ahead.
SJ222.
No, Isabel.
Wait, when data are
Look
saved
at it.
in
Look
the
at it.
primary,
Data is saved in the primary. The primary security group
it
is
replicates
SG.
automatically, right?
Yes. But you have to configure the connection for it to be able to replicate. This is
Okay.
replication.
Okay,
Right.
then it will take SJ444. But if it is down and that it has to continue taking data from the application, that's what I was thinking of.
Yeah, that's called failover. You don't need to worry about that, right? When you configure, there's something called failover. Failover. That's just recovery. So before, when you create everything, when you're done and it's running fine, you're going to configure something called failover, right? So what does that mean? That means that in this subnet and in this subnet, you're going to have, in this subnet, right, this one right here, because this security group is pushing traffic to this security group, right, it's going to allow traffic from SG 44444. 44, how many is 6, 4, 1, 2, 3, 4, 5, 6. Okay, Isabel is right. When this USS1 goes down, when this goes down, and he's no longer receiving traffic or is no longer receiving records from him, if our failover time, there's something called failover time, is 5 minutes, it means that, no, 5 minutes is too low. I think it's supposed to be 15 minutes. If 15 minutes elapse and he hasn't received traffic from this guy, what happens? A coup d'etat occurs. Coup d'etat. He disconnects himself from this guy because there's no more. Let's say this guy goes down. When it goes down, the network is down. So he can no longer send traffic to this guy. So he hasn't received traffic for 15 minutes. He does what? A takeover. He assumes himself as the primary. But during failover configuration, we also, in this security group here, we also allowed what? We also allowed SG 22222 as backup. So in case this guy goes down, this guy can send traffic to this guy directly. Boom. Isabel's thinking the right way. So in this security group, you have to allow. You have allowed this guy and also allow this guy here. But traffic doesn't go from here to here directly. It goes to the primary first, and the primary sends it to him to store it. In case US1A goes down, boom, and it doesn't receive traffic, a takeover occurs, this guy becomes the primary, becomes the master, and say, okay, I haven't received directions or control in the last 15 minutes. So I'm going to go ahead and assume myself as a primary. And now the load balancer will now configure, say, hey, this guy is down. So everything now needs to be going to USS1B. Since he's in USS1B, traffic starts coming directly to him. When USS1A comes back up and it's up and running, and he joins, he comes back online, this guy will say, hey, I'm ahead of you. I have 2 million records. You have 1.8 million records. So you are going to be the standby. I'm going to be the primary. And you'll continue now, you'll now be reverse replication because the security group is still intact. His security group 555 is still intact. Unless you, the engineer, go and say, hey, stop. These guys are primary and you're the standby. So you change the configuration. So you do a manual fail back. It's called a fail back. You fail back to how it used to be. The systems are so automatic. This guy, this standby, he wants to be the primary so bad. It's funny because when I was talking to Amazon, this is how they explain it to us. This standby wants to be primary so bad, right? Because he's receiving data and he's just in a standby mode. Like he wants to be the president so bad. As soon as this guy goes down, 15 minutes elapse, boom, he becomes a president. That's how interesting this thing is. Very, very interesting. You know? Very, very interesting, guys. I love it. I love it. I'm telling you, I love it. Any other questions? Good, man. This is good. This is good. This is making you guys advance, man. I'm not gonna lie. This is making you guys advanced engineers, man. This is great. This is really, really good. Yeah, this is great. Okay. Are we good? Isabel got it. Isabel got it perfectly well. This is perfect. And then what about the ST bucket? Is it in the VPC or out of the VPC?
It's out.
It's out, right? It's like it's out. Of course it's out. Yes, it's out of the VPC. But they're gonna ask in the interview, how do you secure it? How do you make sure that your files are in the bucket secure? You use an SCVPC endpoint. This SCVPC endpoint uses Amazon's private link. It uses Amazon's private link. Private link means that the communication is private. It's not over the internet because the internet is public. It goes through Amazon's own back-end network. There's 2 networks going to AWS. One private channel, which Amazon uses to connect our accounts. It's private. It's behind it is the back door. While the other one is the internet, which is the front door. So this S3 bucket, when you configure it using S3 VPC endpoints, it uses the Amazon's backdoor. That's why you're able to put your files in here, your images, your documents, and then on your website, you're serving content to this website right here. It's not in the VPC because it's going through Amazon's back end. Your VPC is yours. Your VPC is what you own, you create, you define it. The Amazon's back end private link is the backdoor. You don't own it, Amazon owns it. Private link. Private link is the most complicated thing in AWS networking, hands down. I'm not going to talk about it. It's very complicated. It's very hard to do. Private DNS, don't even think about private link. Private link is the most difficult thing in networking, hands down. Before you can configure private link, it is a headache. I'm not even going to advise you guys to think about it. But if they ask you, how do you secure connection between your resources and AWS? Advanced security. This is advanced. This is not basic. It's advanced, right? you're going to talk about private link. But that's pretty much just, say in the interview that private link is very complicated, and they'll be like, yo, yeah, it's complicated. Right? You have to be like a network certified administrator or some expert to be able to configure private. Even me, I don't know private link. I don't really deal with it very much, but yeah. Okay. This is great. Failover, fail back, right? Failover time, 15 minutes. Then he becomes the primary, serves the content. So in the security group here, there's a backup, a security group right here is a backup so that if this guy goes down, this guy continues, right? I talked about only one side, but the same happens for the other side, right? For time purposes, I didn't talk about those other sides. The same thing happens. Okay? So sticky sessions, traffic will be routed to the same instance over and over. So if you go back here and you see that, oh, Kwasi connected to isabelfashion.com to buy a pair of jeans, and his traffic was routed here. Okay? And he added some stuff to his cart. And then he just lit the computer and logged out and left. When he comes back to isabelfashion.com and log in again, that stuff is still in his cart because his session has been stick to this particular instance. So if isabelfashion.com configures sticky a load balancer and they enable sticky session, it's an option. You can tick enable sticky session. Once they enable that, their customers will have better experience. Every time you come back to isabelfashion.com, you're going to be able to see your stuff in your cart. It's still there. However, if Isabel only has 5 pairs of jeans left and Tolu comes and buy all 5 pairs of jeans, then when Kwasi comes back, his cart will be empty. Kwasi, you hearing that? Because if she only has 5 quantity, according to the database, only 5 quantity left, you add it to your cart and you don't buy. When another user comes and buy 5 pairs of jeans, you come back, your cart will be empty. If you care with AWS, try it. With Amazon.com, try it. Go look on an item that says, oh, only 3 quantity left. Put it in your cart, go and come back, someone has bought it, your cart will be empty. They'll be like, oh, sorry, we ran out of stock. But they always do that to improve customer experience, right? You want to make sure that you have a great experience. You're not bothered about, things that you cannot control. Okay? Okay. Good. We're tracking, we're pushing. We are pushing through. Any other questions before we continue? So look at sticky sessions. So this is a classic load balancer, Kwasi. So talk about there are 2 types of load balancers. You have classic load balancer and application load balancer. Classic load balancer just spreads traffic to, once request comes in, another request, just spreads it round robin. Application load balancer is smart enough to say, hey, this is an auto insurance group of servers. This is an home insurance group of servers. So the guy is a home insurance guy, I'm gonna send it here. Oh, here, sorry. If it's an auto insurance, I'm gonna send it here. He's smart. That's the difference between the two of them. This might come in your interview as well. They might ask you, what is the difference between application load balancer and classic load balancer? Application load balancer has advanced routing. It can route specific requests to specific application server, specific task or specific request. Classic load balancer just spreads requests round robin fashion. It doesn't have advanced routing to route to a specific server based on the request, right? So classic load balancer is an original AWS balancer. It operates at layer 4, which is transport. It just transports traffic requests. That's all. It's very, very basic. It operates at layer 4, which is a transport or network layer, as you guys know. It just transports traffic. Application load balancer is preferred because it has HTTPS and HTTP. It's secure. It operates at layer 7, which is an application layer. It can route requests to 1 or more ports on each EC2 instance, right? It can route a request to a specific database, specific thing, right? It can be internal, it can be external. Whereas classic load balancer can only be external. Let me say it again. Classic load balancer can only be external. It cannot be internal. Classic load balancer can only be external or internet-facing load balancer. Application load balancer can be external or internal. Okay, cool. Which of the following statements about ELB is not true? It's not true. Which of the following statements is not true?
V?
What's that?
No, no, no. I'm A or D. I'm confused.
Option A.
You
Yeah,
cannot
I
distribute
think I'll
incoming
go with
traffic
A.
to instances to a
Think
single
I'll go
available
with A.
number. Yes, that's
Yeah.
correct. Auto-scaling. Auto-scaling ensures that you have the correct number of EC2 instances available to handle the load for your application, right? So you can scale up. Vertical scaling is scaling the same instance to higher CPU and memory, while horizontal scaling is scaling out. Horizontal scaling is scaling out to add more instances to your application stack, while scaling in is reducing the number of instances in your application stack. Scale up, scale down is vertical scaling. Scale out and scale in is horizontal scaling. Autoscaling groups. Autoscaling, a collection of instances is called autoscaling group. So you have a group A, you have group B, right? You can specify the minimum number of instances in each autoscaling group. So in autoscaling group, in a group, let's say you have the web app, with the web server group, you have, so you want to have minimum 2 instances in a web server group, maximum 4 instances. So the minimum is going to be 2. If one goes down, autoscaling kicks in and creates another one. So desired capacity here is 2, as you can see here, 1, 2. Minimum size is 1. So at any given time, if there's no more traffic coming in, this one will shut down and this one will remain. When traffic starts coming in, these guys get heavy, one more comes in and it stays right there. And then if traffic goes up, it goes another one. And it goes another one. But the maximum capacity is 4 and it stays there. When traffic is down, it goes back down. So this is called scaling out. Adding more instances in the auto scaling group is called scaling out. While when it reduces down, it's called scaling in. Okay? From now on, we're going to only focus on horizontal scaling. Vertical scaling is not really done, as I told you. Vertical scaling is not feasible because we don't want to have application downtime, right? When I say application downtime means you don't want to shut down your EC2 instance, right? Because you don't want to have downtime. Business is booming, right? We want to keep selling and customers. We don't want to shut down server because we want to do a scale up. No. So auto-scaling launch configuration, because your EC2 instance use an AMR instance to launch, you're going to create a launch configuration. What is the launch configuration? That means that every time you want to create a new and add a new instance, it will use the AMI that has everything installed on it. Remember, we'll talk about AMI carries a software, right? It will use the AMI that has Apache, PHP, all those things already installed in it. So our application servers that are running currently will take an AMI from that and will create a launch configuration. So groups use a launch configuration as a template. What's a template? A template is something that we keep and reuse over and over. For instance, in the launch configuration, specify the information such as the AMI ID that we're going to use, the instance type, the key pair, the security group, and the block device mapping to use. These are the things that we'll specify in our launch template. So that when a new instance comes up, it uses the same AMI ID, the same instance type, the same key pair, the same security groups. Yes, as I talked about. If a new instance is coming up, it has to say use the same security group so that because this guy knows about this security group. This guy is allowing rules from traffic from this security group. So we're using the same security group. So it launches in this security group. So that when request comes to that new instance, the new instance can now push traffic to this load balancer and then load from here to here, from here to here, from here to here. That's why in our launch configuration, there's the launch template specify all these things. All these things, including the volumes, the volume for the instances. So when a new instance comes up, you say, hey, I'm going to use the same security group for the application server. Boom. The same key pair. Boom. The same instance type M35. The same AMI. Boom. So that I'm coming up with the same application that is already running. So I can start receiving traffic. It takes 4 minutes for the application, the instance to come up. And then when it's warm, it's ready to receive traffic. Boom. It starts receiving traffic. Okay. Sorry, guys. Any questions? Any questions before we continue? Okay. Ready. Reloaded. We can take a break soon, okay? So what are the benefits of auto scaling? Better cost management, right? Cost management saves money by launching instances when they're actually needed. If you don't need it, it goes back to the minimum size, 1. So we'll scale down, scale in. When we need it, we'll scale up. So we'll save money. We don't have idle instances running and just wasting money. Okay? That's one thing. So how can you save costs? Use auto scaling. It can be used with elastic load balancer to distribute traffic across the groups, right? That's a benefit. There's better availability if you use auto scaling groups. Ensures that your application always has the correct capacity. Capacity is what? CPU or memory. The correct capacity to handle traffic demands. Isabelfashion.com is a business. It needs to sell orders. So it needs to have the correct capacity to sell orders. Those servers need to run and process customer orders. What's processing customer orders? Charge the credit card, create a shipping label, send them an email with their order number. So those servers need to have compute capacity to do that stuff. That's why it's important to use auto-scaling groups. Multiple availability zone. If one availability zone becomes unavailable, auto-scaling can launch instances in another availability zone to compensate that capacity needed to run isabelfashion.com, to run the business. This is all about business, all about making money. IT is the key to companies making money. That's why IT people make a lot of money, because they want to pay you to make sure that the business has enough machines to run the business, right? This is how we make money. We make money by selling orders online, and those orders online are processed by servers. So we manage those servers for business. So we make money. So they gotta pay you to be able to make sure that the servers are up and running all the time. Okay, and then better fault tolerance as well. We're able to detect when an instance is unhealthy, terminate it, and launch a new one to replace it. The load balancer does what by doing this? Health checks. Health checks. Okay? Any questions here? This is something that you need to know. If I were you, I'll screenshot this and put on my phone. This can come in an interview. Auto-scaling. These are the questions that come around auto-scaling. What's auto-scaling? Can you explain what auto-scaling is? What are the benefits of auto-scaling? How does auto-scaling work? This is it. This is the answer here. All these things that you see here, this is the answer. If I were you, I'll screenshot this page and study it. If you want to cram it, but this is important to know. Okay? Okay. Now let's check. Why would you use auto scaling?
Option D,
Mhm.
Okay, option D is correct. Ensures that you have the correct number of instances available to handle the load for application using auto scaling groups. Okay. We're not going to do lambda. We're going to skip lambda. Beanstalk, we're going to skip that. AWS CLI, let's talk about CLI real quick. I think we'll talk about it, but let's just go over the notes. Amazon CLI is a command line interface. It's a unified tool to manage AWS services. With just one tool to download and configure, you can control multiple resources from the command line and automate them through scripts. So Amazon CLI can be installed on Windows using the MSI installer, Linux with pip. Amazon Linux AMI is pre-installed with AWS CLI. Okay, you can copy files to S3 using the CLI. You can restart instance using the CLI. You can configure CloudWatch alarms using the CLI. You can get information about AWS about the CLI. Okay, that's that. It's the cost. What is the key purpose of the AWS CLI? Let's just go through this quiz real quick, and then we'll take a break. When we'll come back, we'll begin Terraform configuration. What is the purpose of CLI?
A.
A.
Okay. Yep. Yep. No, no, go to this one. EBS volumes are. EBA volumes are. I think we did it on Monday. What are they?
B.
B.
Block-based storage. Can you detach EBS volumes that are not root volume without stopping the instance? Think about the engine of a car. Can you remove the engine of a car without stopping the car? That's the same thing. Let's give you guys an answer.
Not
What's the
B.
answer? Can you detach EBS volumes that are not?
that are not. Oh,
Hey, that not always catches people in an interview. You can detach EBS volumes that are not root volume. The root volume is the one that you cannot detach. Additional volumes you cannot detach. So you can detach non-root volumes. The root volume is the engine of the car. You can detach the chair of a car without turning off the car. You can detach the windshield wiper. But the engine, you cannot detect it because the car will turn off. Okay? Cool. And that's that. Configure ELB, test it, key takeaways, and we are done. Done, 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 done. So it's 8:23. Let's take what? How many minutes should we take? Then we'll come back and we're going to start from. How many minutes should we take? 5, 10 minutes? Because we're going to 10 p.m., right? Are we ready to go to 10 p.m. or we want to go to 9:30? I kind of said it before, right? So I'm going to show how you can configure a development environment from scratch, right? So first things first, I want to download VS Code. For those who have never done this will benefit you. I'm gonna be a little bit fast because most of you have done it. I'm not sure about Chris, but So VS Code is the first thing I'm gonna download. VS Code is a development environment. It's an IDE. It's an integrated development environment tool. So for Windows, I'm gonna download it for here, and I'm gonna run the installation. When I say download the software, obviously you have to download and install the software, right? You have to install it. So like, when I install this software, I accept the agreement. My brightness is not all that. Let me increase my brightness. It's better for my eyes. Install. Next. Register code as an editor for supported files. Add to path. This is very important. Create a desktop icon as well. Next, install it. So install the software. Done. Launch to it was click finish. You're going to launch the studio. Boom, and that's it. Right? That's Visual Studio Code. Now I'm going to go open up terminal, so CMD, run as administrator. Yes. And I want to go to Google and I want to install Chocolate. Chocolate is a package manager for Windows. So I'm going to open up Chocolate and I'm going to follow the steps. I accept the cookies. So get started. Go back, and just installing Chocolate. So this is the steps to install Chocolate. And individual steps. Step 1 is the administrative shell. So administrative shell, so I have it as administrator. You see, system32 means it's administrator, right? So that's the shell I'm running, right? And the first command I want to check is to make sure that the policy is all signed, right? So I want to run get execution policy. I'm going to Control C on my keyboard and copy that. And I'm going to Control V and paste that. It's not recognized as an internal command. So go back again. Um, let's see. Get execution policy. Hmm. Let me copy this command and run and see what happens. I think we had to use PowerShell, right? Maybe we had to use PowerShell. Let me close this. Let me open again. System. Run as administrator. Yes. IF config. Something is wrong with this thing. I'll try using PowerShell. PowerShell. Not as a user. I want to run as administrator. PowerShell. Run as administrator. Let's see if it works. System32. Let's use PowerShell. Get execution policy. It's a brand new laptop, so maybe that's how it was set up. So it's restricted. So if it returns restricted, then run set explicit policy all signs. Then I want to run this. You see, it says here, right? You can use a shell, or you can use a non-administrative installation as well, or you can install with PowerShell. So that's why I'm doing PowerShell. Okay. Chocolate is a package manager for Windows. You can install all packages easily and upgrade those packages, manage them with Chocolate. So it's important for us to set up Chocolate. So I'm going to say yes to all by just typing this capital A, yes to all. And that's it. Now I can run up arrow. I'm doing up arrow on my keyboard. Get the policy again. It's now all signed. Now that it's all signed, I can go ahead and run this command. Control V and enter. It's going to install Chocolate. And that's it. It's installed. Now we can check by just saying Choco install Terraform. It's going to install Terraform for us. Yes to all. A. It's downloading Terraform 1.105, which is the most recent version. That's it. Next thing, Choco install Git. Boom, installing Git for us. Yes to all. Okay, it's done. So now if we go back to VS Code now, and we open up a new terminal right here, terminal, new terminal. We can see it's PowerShell. We don't want to use PowerShell, so we can click this little arrow here and say configure terminal settings. Oh, sorry, select default profile. And we can click the git bash here, and it will change our prompt. Come on, it's loading. Now we have git bash because we installed git. And now we can run Linux commands on here. ls-ltr. You can see, right? We can cd into documents folder, ls-ltr. All right, it's empty. And here we can do a create a folder, mkdir terraform -aws. Now if you do ls-ltr, you can cd into terraform tab terraform -aws. Play your screen, boom, you're in there. And now you can go now to file and open that terraform.aws folder in documents. Here, you open that folder and boom. Yes, I trust the authors. Close this guy out. And now you can start creating files here. First file I want to create is your provider.tf. Boom. Enter. And it's empty. But you want to install extensions, right? Terraform extensions, syntax highlighting, beautifying colors, and all that stuff. So you're going to go install Terraform syntax highlighting right here. HashiCorp Terraform. You install that. Trust the publisher and install, yes. These are just things to help you highlight your syntax so you don't make any mistakes. Then you want to do Terraform autocomplete. So you help you autocomplete your code. Autocomplete right there. Install. Trust this. That's gonna autocomplete for you. And the last thing you want to do is AWS CLI. AWS CLI. And install that. Why is it always asking me for this? And that's that. Why does it have to be here? Hide badge. Hide. Why does it have to be here? Move to, it's okay. You can stay there. Okay, so now provider, when you want to configure a provider, right, AWS, curly bracket open, region equals US dash east dash one, right? That's it. You save the file. Okay. And now we can go open up that document. I'm going to put the document in the chat. In the chat window, where is it? This is what we want to create, right? This document here. Right? So this is the document I want to create. So I'm going to look at it on my other laptop here and I'm going to type the code in. Okay. But first, right? That's how we configure development environment for Windows. Any questions on anything that I missed? If you wanted to check your versions, this is what you would do. In your terminal, you would just do a Terraform dash dash version. Terraform dash dash version. Enter. Am I typing it correctly? Terraform dash dash version. I have a colon in there. No. Okay, you know what? I need to close VS Code and reopen it. I believe so. And reopen it. So it takes effect of what has been installed. So you can clear screen, Terraform dash dash version. That's it, right? I want to install more packages. Don't install packages from VS Code, right? Go to the System32 right here. System32 is your administrator, and then install from here. Let's say I want to install. What else we want to install? Docker, Choco, install. Let me hide this prompt thing. Hide floating controls. Choco install Docker. So I'm gonna install Docker for us.
D-Way is waiting for your answer.
Yeah, man. I'm getting tired, but it's okay. We'll push through. Okay, so that's that. Okay, so I'm gonna stop sharing on this side, and I'm gonna log into AWS. Let's create a load balancer real quick. Okay, then we'll do Terraform. But let's just create it real quick with where's the Zoom? Stop share. And I'm gonna share on this MacBook. Let's do it with so we're gonna go to AWS. Okay. So what we're gonna do here is we're gonna create two instances. So you can watch while I do it the first time, right? You can just watch, right? You're gonna call this server one. Come on. Server one. Are you gonna just launch it?
You're not seeing your screen, Jibo.
Oh, sorry. Share screen. I'm going to launch it on EC2 instance. Call it server_1. Linux AMI. Key pair is Linux practice. Everything allow HTTPS and this. Use the same security group, right? Remember that? So I'm going to use launch reset 3, right? And launch instance. Then I'm going to go back again and launch another instance. I'm going to call this server 2. Just watch for the first time, right? Just watch. We'll do it together. And then Linux. Remember when I talked about the launch configuration? That's one thing you need to pay attention to, right? Let me go back there. The launch configuration has what? The same AMI ID, same instance type, same key pair, same security group, same device block mapping. So as you can see in server 2, I'm choosing the same key pair, Linux practice. I'm choosing the same security group, launch wizard 3, right? Same thing, same security group, same key pair, same instance type, same AMI, same, and launch instance. So I have 2 servers now. What happened? What? Retry failed task. I cannot create more than one EC2 instance? You're kidding me. Why is that? Thing is because of my billing issue. Anyway, it's fine. I don't really care. Okay, so once you have your EC2 instances and you go to load balancers, I'm going to create a load balancer. It'll give you these options. Like I said, back in the day, we used to have classic right there. It's previous generation. Classic is basic, right? It's just when you have an existing application running in EC2 classic network. We don't use it anymore. That's why you say it's in period. We don't use it anymore. We use what? Application load balancer because it's advanced. Choose an application load balancer when you need a flexible feature set for your application with HTTP and HTTPS traffic operating at the request level. What does that mean? It means operating at the request level, meaning that it knows your requests. If you go to geico.com's auto insurance, it will send your request on auto insurance application server. Even if it's front facing, it will send your requests on web server that is all about geico.com/auto insurance. It's smart enough, right? The previous one wasn't that smart. That's why you see it's not even showing here as an option. It's the old one, so it's gone. Quasi, take note. Classic load balancer is gone. Application load balancer can be internal or external facing. Take note of that. Don't let the name fool you. Application can also be used for web servers as well. Operating at the request level, application load balancers provide advanced routing and visibility features targeted at application architectures, including microservices and containers. It means it can target specific things. You can have an application that has auto, home insurance, boat insurance, life insurance. That's an application, but each of those have their own group of servers. Auto insurance can have 4 servers. Boat has 4 servers. Life insurance has 4 servers, group of servers. So the load balancer can send the request to the group based on the request from the client, from the customer. Okay, so we're going to create application load balancer. And we're going to give a load balancer name. We're going to call this Isabel-fashion. Not .com, Isabel-fashion. Not .com. In the load balancer name, since it doesn't have an IP address, right? This name will be attached to the load balancer, and they will map this name to the isabel.com isabelfashion.com. And so everything coming from isabelfashion.com will hit this load balancer. This name is just for us to recognize that this load balancer is meant for isabelfashion.com. Your options here, it can either be internet facing or internal. Kwasi, are you here?
Yes, sir.
This is what you were talking about. This is application load balancer. It can either be internal. If you want to know more about it, you can expand it. You can see how it works. Clients make requests to your application. The listeners in your load balancer receive requests matching the protocol. You can read about it here. But this is it. We're going to do internet facing, sorry. You're going to choose your IP stack, IPv4, means that your applications behind the scenes means that institutions are using IPv4. Doesn't mean that you're going to have an IP address. No, load balancers don't have IP addresses, right? They have a cluster, they have a DNS name. They have a DNS name that maps the domain name. Boom. Network mapping. You're going to pick the security group. We only have one security group here. Sorry, VPC. Boom, that's the VPC we have. We're going to pick our availability zones that we want all the security group, the load balancer to be in. If we want the load balancer to be in all availability zones, we're going to check all the boxes. You see? Each one has its own subnet. Oh, Debo, it makes sense now. Yes, it makes sense. You see that? The availability zone can belong to more than one subnet. It can belong to more than one subnet. In this picture here, we just have one subnet, but it spans multiple subnets. It spans multiple subnets. Like here you have this, it spans multiple subnets because of the high availability nature of it. So we can just choose two for simplicity's sake. It's one and this one. US1A and US1B. As you can see here, you have US1A, US1B. So in this case, this load balancer is currently sitting in US1A and in US1B. So you can send traffic to US1A and US1B. In the diagram, on the diagram that you will see on the job, right? It will be like this. I didn't draw the diagram correctly. I'll fix it. Like this, boom. And then you have US East 1. Boom. Right there. Like that. Boom. So, but we know that we always selected two AZs, A and B. But we can always go back and modify and add more, pam, 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 and come back and add more subnets, pam, 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 and expand our application and scale up. This is what they call scale up. When business grows, we add more, we scale up, we keep going up and up and up and up. Any questions? Is it clicking now? I want to make sure that we're clicking. Yes, it's clicking.
No.
What's not clicking? Ask me a question. What don't you understand?
Oh, you were asking question if your thing's clicking.
No, I'm saying if clicking me, are you understanding?
Oh, okay, but I don't know this.
Huh?
Yeah.
Are you understanding what that's what I remember? Is it clicking?
Yeah. My own's okay.
Okay. Cool. So let's go continue creating it. US1A, US1B. Security group. What did we choose when we were creating our instances? We do choose Launch Wizard 3. So what do we choose here? Not Launch Wizard 3, no. This load balancer will have its own security group. We can choose something like Launch Wizard 5, right? You can multiple, but we're just going to choose Launch Wizard 5. And then we can leave the default in there, or we can remove it. And then in launch wizard 3, we're gonna allow SG00 this, right? So listeners and routing, we want HTTP protocol, we want to select it to the target group. We don't have a target group yet, so we can go create a target group. Want to put what do we want to put behind a target group? We want to put instances behind a target group. So we'll give a target group name, call it Isabel -fashion target group, TG. This is the group of servers that we want to put our under a load balancer. Okay, so the protocol is HTTP. You can choose HTTPS, but it requires you to have a certificate. We don't have a certificate right now, so we're gonna just keep it HTTP. But this is how you configure it. Port 80, the same VPC. Remember, everything in the same VPC. Remember, everything is in the same VPC. Quasi, everything is in the same VPC. It's one VPC, but everything is different subnets and security group, but it's one VPC. So we're gonna come here, health checks, HTTP health check. You're gonna put the health check name. This is what the health check file will be, index.html. Index.html, right? Advanced health check settings. So this is the threshold we're gonna set. So when does the load balancer know that the instance is healthy? How many checks will it do? Is it 5 times or is it 3 times? Let's do the minimum. Let's do 2 times. It means that it will say, hey, are you there? Yes, I'm here. Are you there? Yes, I'm here. Okay, you're healthy. Then unhealthy, we'll do 3 times. Are you there? Doesn't respond. Are you there? Doesn't respond. Are you there? Doesn't respond. He marks him healthy. Sorry, unhealthy. Then timeout. The amount of time in seconds during which no response means a failed health check. So, are you there? 1, 2, 3, 4, 5 seconds. Check again. Are you there? 1, 2, 3, 4, 5 seconds. It doesn't respond. Are you there? The load balancer wait. 1, 2, 3, 4, 5 seconds. After 3 times of checking, and he waits 5 seconds, no response, he marks him unhealthy. After 2 times of checking, so are you there? For healthy is on. Are you there? He waits 1, 2, 3, 4, 5 seconds. He responds. Are you there? Within 5 seconds, he responds. You're healthy. If I check 3 times and I check the first time, 5 seconds, you don't respond. Second time, you don't respond. Third time, you don't respond. You're unhealthy. So that's it. And the interval is the appropriate time between the health checks. So when I check now, after the 3 times is over, I mark it unhealthy. How long do I wait before I come and check again? 30 seconds. I can do up to 1 minute. That's what this is. So if it's healthy, it gives a success code 200. If it's unhealthy, then it's a failure code. And that's it. You create next. You put the instances that you want. You have more than one instances here. You check the instances that you want to add to the target group, and you create the target group. And that's it. You have your target group. You have 0 unhealthy, 0 healthy. That's Isabel Fashion TG. Now you go back here, you refresh it. You now have a target group. Select a target group. So this is either it's your load balancer, and all this is just extra things. You create your load balancer, and that's it. Now this is your load balancer. All traffic coming to this load balancer is going to be forwarded to what? This target group. And the target group has what behind it? Health instances. This is a health check. It's not checking yet. Monitoring is there to see if it's targets. That's it. Register targets. That's the instance that needs to be registered, right? Include as pending below. Register pending targets. So that's the server. Boom. Health status is initial. Target registration in progress. It's now registering this instance with the load balancer. So now all traffic that's going to come to this load balancer, this is it. This is the URL. This one. It's not probably not because we haven't configured it. So this URL, this name, the last load balancing dash, this is a best fashion. This is where you're going to go to attach. This is where you're going to attach to. It's abetfashion.com. Right? Sorry, it's too big. So if you go to isabelfashion.com, your traffic is actually going to hit this load balancer. And then before this load balancer, I'll send the traffic to their web server. So you're not going directly to this. This load balancer here, this is it here. This is the name of it here. That's it. So this guy is actually hitting this load balancer first. And that's the URL for the load balancer. Hold on, am I correct? No, that's not the URL. Sorry. That's wrong. This is the URL, this one. .com. Sorry, guys. My bad. It's been a long day. Not this one. This one. It's always going to be a .com, right? So when you go to isabelfashion.com and you send a request, it comes to here. Isabelfashion dash this is that .com. This is it. Is it clear now? You see how it works now? So the load balancer receives your traffic, receives the request, and just forwards it to the services, the instances behind it. That's all. That's all about load balancer. Once you configure that, it registers, that's it. You're done. Refresh this. It's still initializing. Registration is in progress. It takes a while to register, right? Because those are all the health checks. You're going to show up here healthy. If it's unhealthy, you show unhealthy, right? So that's it. Questions, concerns, comments? Do we want to go out and create a load balancer now or want to do the Terraform work? Should we create it on the console first before we do the Terraform piece you guys created? It's showing unhealthy, right? Because we haven't configured the health check, right? The health checks means we have to go into the EC2 instance and create this file, index.html. On the EC2 instance right now, there's no file called index.html and on that EC2 instance. So obviously it's going to fail. The health check failed. That's why it's showing unhealthy. But if we do this exercise, which is showing us the load balancer, this exercise, if we do it all the way, you will see it show healthy. Where is it? Right here. You will see it show healthy. You see that? Port 80, it will show instant target group healthy. Okay? So that's that. Do we want to go and create it with on the console or want to just Terraform?
And then Terraform.
This is the Terraform right now? Okay. Let's begin Terraform then. Okay? So I'm going to stop sharing and then I'm going to share with my Windows machine. And let's type some code. Again, like I said, we're going to go to 10 p.m. So I hope nobody is feeling tired and ready to leave, right? Persevere, guys. Persevere. I'm tired as well, but let's go to 10 p.m. Okay? Tolu, I know it's late for you. Can you persevere for another 45 minutes?
Yeah.
Okay, cool. Thanks for your considerations. I know it's early for Chris because I think he's in California. So I'm going to type the code, okay? I'm not going to copy it. I'm going to type it in. Which screen can you guys see? My Terraform screen, right? My VS Code. Yeah?
Yep. Terraform.
Okay. Cool. Okay, cool. Sorry, I'm distracted here. We're not going to read the jargons. We know what we want to do. Let's start by configuring the credentials first. Also, make sure the latest version of Terraform installed. So when we do credentials, let's do credentials first. So I'm going to stop sharing here and share on this side so we can go to AWS console and create credentials. So I'm going to go here. Load balancer can be very expensive, so I'm gonna go ahead and delete the load balancer. They're very, very expensive. It's not cheap. I'm gonna delete it right away. Delete load balancer. Confirm. Delete that, and then delete the target group as well. Right. Delete the target group, and then delete the EC2 instance. Okay. And let's go to IAM and create credentials. So I'm gonna use an existing user. I'm not gonna create a brand new user. You can use an existing user like Terraform right here and security credentials and just create access key for the AWS CLI. Understand. Isabel is gonna get twice. Isabel, don't try to run it while I'm running it right. Just watch. Just watch because I'm going very fast, right? Create access key. And then I'm gonna take this access key and put it in I want to use this access key in my configuration on this side. So I'm gonna put it in the chat and I'm gonna go back and go down and grab it. Please do not use a key. Please do not use a key. Please do not use a key. I need to use it. Okay. I'm gonna stop sharing here. And I'm gonna go here and I'm gonna share. And here I'm gonna do AWS configure. Come on. AWS. Oh, the CLI is not installed. CLI is not installed. Choco install AWS CLI. Okay, it's done. So I'm gonna go back here now and AWS configure. I gotta close it up and reopen it again. That's the thing. Every time you install something new, you gotta relaunch VS Code. A new terminal. Oh, the terminal is right there. I'm gonna just clear my screen. AWS configure. And I gotta put the key that I just created. Access key. I'm gonna delete the keys right after class, okay? Don't configure terminal settings. I'm gonna copy the secret key as well and keep it in the cache. Delete this stuff, man. What happened? Enter, and then paste the secret key. Enter, and then US-east-1. Enter. So AWS version. And that's it. That screen. And now I can begin typing my code. So the next thing, I don't have the, so guys, just follow through on this document. Where is it? Was in the chat, right? Just follow through with me on this document right here. Okay. I can't share the document and type at the same time. So I just did AWS configure. The next thing is to configure lists. You're going to show this, and then we're going to begin typing the rest of the stuff. Okay. Like, we're not going to go through this because we already know we want to just go into the code. If you want me to explain this, it's pretty much a load balancer, the application load balancer file, the instances, the main.tf output, security groups, and the variables, right? So we're going to start the AWS ALB file. So we're going to create a configuration, set up the VPC, create the load balancer, select a public subnet, attach security group to it. The same thing we just did to the console. The same thing we did on the console. It's the same thing we're doing here by using Terraform code. The reason why we do it with the code is because we can do it over and over and over. We can just run the code over and over and over. With the console, you have to click, 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 click. So it's easier to just have the one code, write the code one time, and just apply the code over and over and over. Okay? So here, we're gonna go ahead and target group, define the health check, configure port protocols, attach the web instance. What we just did, attach a web instance to create listener configuration, and then load balancer is ready. So here is the code. Boom, here is the code. Let's go ahead and write that code. So I'm gonna look at it on this side and then type it here. So first file that I'm gonna create is alb.tf. That's it. Guys, I'm sorry. For time's sake, I think we'll just copy it and paste it, man. I'm not gonna lie to you. It's already 9:22. I'm gonna just copy and paste it. Okay. Time is on our side. But like I said, where is the file? Okay, it's here. I'm gonna just copy and paste it, guys. But again, for practice sake, you shouldn't copy, right? Um, I know Terraform, so I don't have to learn Terraform. So I'm gonna just copy because time is on our side. And I copy using my keyboard. I don't do a mouse scroll down. And Control C.
Dimo,
Yes.
if just a proposition, I finished writing the code since last time,
You
but I
did?
was not able to run it. If one can share my screen and
No, I don't know you, man. You might have made a mistake somewhere, man. I don't want to deal with you.
yeah, exactly, yeah, I did,
You made
but
a mistake.
I didn't, I was not able to perform the
Yeah,
test.
yeah, yeah. It's okay. It's okay. So let me explain the code. This is a application load balancer code. So this is the name of the load balancer. It's a web load balancer. So it's internet facing. It's an application type. We're gonna put a security group that we're gonna use subnets, right? Target group, right? It's gonna be in our variables file. This is the health check that we're doing. It's a slash. Our threshold is two times. Unhealthy is 10 times. I think it's high, but it's okay. So he checks 10 times before he marks the instance unhealthy. 10 times. But he checks two times before he marks the instance healthy. Okay. This is a target group attachment. It adds a target group to the web server 1 and then to web server 2. Okay. All of these variables are going to be kept in the variables of TF that I want to create. This is the listener configuration. It's listening on port 80. So the load balancer is listening for anything coming from HTTP on port 80. It accepts it. If it's coming from a different thing, it rejects it. That's why I said load balancers are great because they only accept traffic that's coming for business. If you're going to go to someone's website, you're going to go to HTTPS or HTTP. That's it. You're not going to go to SSH or some other different protocol or TCP protocol or UDP protocol. It's going to reject it because we know that HTTP and HTTPS is the protocol for web applications. So that's why it's only going to listen for HTTP protocol. Okay.
I did not see the time interval on this.
No, here is the time interval up here. You're right. Hold on. Maybe it's down. Hold on. Let me go back to the code. You're right about that. Let's see. False. This block's create a name. Target a healthy threshold. I think they're assuming the default, right? The default is 30 seconds, Isabel. The default is 5 seconds for the timeout, and then the default interval is 30 seconds. So if I go back here and I show you target group, let me just show you this real quick. Here. This is the default for timeout, 5 seconds. So if they don't put it there in the code.
I'm not seeing that screen that you're showing.
Oh, sorry. Let me stop sharing and go here. If you don't see it in the code, here, I went to EC2. I went to target groups. I created a target group. And here in the health check, it's an advanced setting. You don't need these settings to create a load balancer. This is an advanced setting. This is optional. If you don't set these things, these thresholds, it takes the default values. Does that make sense? These are the default values. You see right here, restore defaults. These are the default values here. Default. This is a default, right? But in the code, they're not using the default. They use 2 for healthy and 10 for unhealthy. You can come here and add another line for timeouts, another line for interval, but they did not do it because they want to reduce the amount of code that you write, and you're going to just use the default. The default is 5 seconds here. The default is 30 seconds here. Sometimes on the job, you don't want to repeat the same thing that is obvious. If you're going to just keep it to 5 seconds for the timeout and interval of 30 seconds, no need to put it in your code. Because what happens is you're going to end up having a voluminous code. Remember, in VS Code, we have lines, right? There's line number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't end up having 3,000 lines of code. This is considered one line of code right here. One line, 2 line, 3 line. So if you keep adding things, you're going to end up having 3,000 lines of code. It's stressful. If it's a default value that you're going to reuse, just leave it out. They changed these values to 2 because the default is 5. They changed it to 2. They changed it to 10, but the default is what? 2. So if you're going to change a value, then put it in your code. If you're going to use the default, just leave it out. It just saves you time and saves you writing extra code. That makes sense? That's one of the principles of coding. Do not repeat yourself. It's called, it's a principle about coding. It's called DRA, coding principle. DRA. Don't repeat yourself. Don't repeat yourself, Isabel. If something is a default, just leave it as default. Don't repeat yourself, okay? Cool. Is that cool? Are we cool with that? So everything you don't see in the code, it's considered the default, okay? Don't reuse, don't repeat yourself, okay? Cool. Okay. Share my screen again here. And I've copied the code. I'm gonna hide floating controls. Okay, what else is next? Uh, height, floating, meeting controls. So I've copied that ELB. I'm gonna save that file. Save. Go back to the code. Creating target group. Location load balancer. Oh, this is just explaining the code. ALB on so web. Yeah, it's just explaining the code, right? I want to just, yeah, we're just go create the files, creating a listener. It's explaining what it is. Next thing is the instance.tf. I'm going to just copy instance.tf. You can read through this, right? If you want to understand the code, right? Just for time's sake, I cannot do that right now. New instances. Instances.tf, because it's more than one instance, okay? That's here. I might not be able to, come on. Because of this billing issue, I might not be able to create an instance, more than one instance. So you see, this is how you install Apache from Terraform, right, to configure the server. This is that file I was talking about for the index or HTML file. This is the file that the health check goes against. It checks this file by pinging this server. So it's creating those two files. Okay, cool. We have some problems already. No declaration file and valid instance type, but we're going to we're going to solve that. So I'm going to go ahead and save this file. Save it. Because we need to create a variables or TF file. So the next thing is to come scroll. It explains the code. That makes it long. So main.tf, this is the VPC configuration. VPC, internet gateway, route table, security group, subnet. Right? So this is the main.tf. This is the main file. They put the provider block in here, but we don't need to put the provider block in here because in our code, we have a provider.tf file that has a provider block already in there. So we're covered. We don't need that, right? So we're going to create a file called main.tf. This is the main file, main.tf. That runs the code. And then we're going to go copy that code. So I can copy this part or I can leave it. Doesn't matter, right? Doesn't matter. For simplicity, I'm going to just copy it, but it doesn't matter. So you're creating a VPC. Quasi, we're creating a VPC called main VPC. We're creating an internet gateway. We're creating subnets. You see, we're hard coding the value of our subnets. 10 does it to SAS24. SAS24 give you how many IPs? SAS24 gives you how many IPs? They thought we were done. uh, SAS24 give you how many IPs? It's okay. You're not yet senior engineers. You don't know.
256.
256.
How many?
256.
How many is usable?
14, 251.
Okay. Sorry, I'm laughing. It's just like, well, I've gone through this. Well, I've been through this multiple times, so we know what we're talking about. Okay. You're correct. Perfect. That's a senior engineer knowledge. It's not for junior engineers. Knowing IPs off head is not for the weak at heart. Trust me. It's a numbers game. It's not for newcomers. So this is the main.tf file. The next file we want to create is output.tf, which is not very important. It's just one file. This will output the DNS name. That isabelfashion.com, that long name, this is gonna output this name for us. So I'm gonna just copy this code and create an output.tf file. On the job, you will do this because there are times when you need to output the EC2 instance domain name or no. So you need to output file. So you have to learn to create outputs.tf. Outputs. Always do outputs. Always do puts with an S, variables, outputs, instances, because on the job, you don't create one thing. There's never going to be time you create one thing. Even if right now you're going to have one output, but the next time you want to add something to this configuration, you're going to have another thing in there. So you want to always plural outputs, variables, instances, right? Users, roles.tf, policies.tf, right? Always have plural in your naming convention. That way, then you can scale, you can add more things, right? So here I'm going to put the outputs and I'm going to save the file. Always save the file. Oh. Kwasi did not save his file. That's why it did not run. Kwasi, you didn't save your code, man. Come on, be giving us stress here. Security group.tf. This is a big one. It's a big one. Without this, nothing will work. Without security groups, nothing will work, guys. Trust me. We're going to go create security groups. It says security.tf, but I prefer to call it security groups, but all right. I like to call it security groups. So here, security underscore groups, because there's more than one security groups, right? And paste that file in there. See, there's one for the load balancer. There's one for the instances. You see that? You saw how the diagram that we did? There's security group for load balancer, security group for instances, right? And then the final thing I believe is the variables. Lastly, are you done teaching the class? Teach the class. Okay. It's explaining the code for security group for the instances, explains the code for security group for load balancers, and that's it. And then the last thing is the variables.tf, variables.tf. And these are the variables, right? The region, the instance type, and then the startup block for the VPC.
I have a question. Must we follow this order for it to work? Oh,
It's just best practice, to be honest with you. It's just the best practice. It's just the right thing to do. You can follow whatever order you want to follow, but there's a saying that when something works, don't change it, right? You can follow any order you want to follow, but it's just best practices to follow this format. It works, right? So why change it, you know? So, but yeah. Okay. Any other questions before I start running things? I'm gonna copy variables and I'm gonna paste it here. We're almost done. Variables.tf. When I paste this variable.tf, all these problems are gonna go away because now they will have their definitions. See? No declaration found. Region, startup block, region, instance type. And now when I create variables.tf and I paste this, boom, everything problem goes away because now I'm defining the variables, right? And I explain it. Save the file. If you go to instances.tf, what does it say? var.instance type. Instance type is var instance type. If you go to variables, say var. Var means variables. Instance type. If you go to variables, look at that. Variable instance type T2 micro. So it's going to come and look in this file. It's going to come and look in this file and then pull the variable T2 micro. Same thing here in the main.tf, VPC up here. Where is the VPC? var.vpc starter block. So it looks for VPC starter cider. It comes in here and looks for VPC starter, and then that's a value. It takes a value and it puts and it passes it here and uses it here. That's how variables work. That's how variables work. That's how variables work. That's how variables work. Okay. Any questions on variables? We'll do some more practice, right? Look at this. Look at this one. Now the VPC ID is VPC. The internet gateway is going to create in what VPC? In the main VPC. Where is the main VPC? This is it here, called main. Right? So what's the first thing that's going to create? This VPC creates first. And then the internet gateway creates second. And then because public subnets needs to have an internet gateway, this internet gateway creates first before the public subnets create. Right? In which region? var.aws region. We go look at the variables region. US is 1. And then it's going to pick an availability zone randomly. So we're hard coding this value. In this VPC, public not create my public IP on launch true. Tag name public subnet. Down here, same thing. Boom, done. Route table is open to the world. Internet gateway, because of if you want to have a public subnet, you need this route. Internet gateway 000. So gateway ID. So we're going to put internet gateway.main, which is this one right here. Internet gateway.main, this name right here. This is it here. .main, that's it. And then you associate your subnets with the route table, public route table, and this one. And that's it, you're done. This is called subnet association. Route table associate with the subnet. You put the subnet ID, public one.id is from where? Public one. This is it, public one.id. And public two.id. And that's it here. .id. And then the route table name is the one that you created up here. Public route table. That's it, public. You associate the two, and that's it, you're done. Network is done. Okay? Security groups, name security group, give it a name, create a new VPC in the main VPC. This is the inbound rules. Allow port 80 to port 80, TCP type connection. Attach it to ALB. This is attached to ALB. Security group.alb.ie, attach it to ALB. Egress ports, allow everything that comes in to go out, meaning that it's what? It's stateless, right? And then security group this is for instances. So you're allowing everything for the instances, security group for the instances, you're allowing everything from the Elastic Load Balancer from the application load balancer to come into it. That's what this means. Allow everything from the load balancer, which is running on port 80, to come into my instances. So put the security group ID for the load balancer in here. Right here, ALB.ID. So the security group ID, we talked about that. The security group ID that for the load balancer will be allowed in the security group of the EC2 instances. So ALB.ID will be allowed in here. And then here, for the security group for the last load balancer, we're allowing everything from the internet because we'll have these routes. and everything that comes in goes out, and that's it. This guy is not allowing anything from the EC2 instance. It's instead pushing traffic to the EC2 instance. So he receives from the internet, which is this route, and push to the EC2 instance. And how? By us allowing his ID, ALB.ID, to connect to our security of our EC2 instances. And that's it, done. Now we can run our code. What else is there? So here, all codes, files and extensions are done. Hope you understand. And now let's move on to running the Terraform code. Init, plan, apply, done. So let's see what errors Quasi was talking about. Let me save the code. Save. So take note that what? For the instances, we're going to pull an existing AMI from AWS. This is called data sources. Data.aws ami.this Linux 2. This AMI might not be available because Amazon Linux 2 is no longer supported. So we might have to check, we might have to either hard code the AMI or change how we pull the AMI. So if it failed, it's because of this AMI, right? So I want to make sure that we know that because this is an old code. Amazon Linux 2 may not be available in AWS right now. The AMI may have changed. However, I want you to see that error, then I'll show you how to fix it. Okay? Right now, we want to pull the existing AMI in AWS. And at the time of this guy writing this document, Amazon Linux 2 was available. But if Amazon Linux is no longer available, then it will fail. So we're going to have to go and copy a current AMI ID, and we're going to put it in here, and the code will succeed. Okay? Now let's go ahead and run our code. Any questions before I run the code? New terminal is going to open up PWD in that Terraform folder right there. Boom. Okay? So the first thing is what? I'm going to close all these guys because I want peace. I want to have a clear eyes. Whenever I want to run Terraform, I want peace. I want clear eyes. I want to just close them. They're all safe. If you were closing them and they will say, hey, do you want to save the file? It means it wasn't saved. So the way I know it's saved, because it's not asking that question, do you want to save this file? So now I know it's saved. Classic did not save his own. It was in a rush. So now I'm going to run Terraform init. Whoa, all kinds of errors pop up. Let's see what it's asking for. Why is this not scrolling going up? Let's see. Configuration described. Terraform duplicate provider. Remember I told you that we already have a provider in here. Yeah? We don't need to have it in the variables. Or we don't need to have it in the main.tf. Right here. You see that? So we can remove it we can delete this file. Since I did not have it at all. So we're going to delete that file. Move to recycle bin. Okay? Duplicate provider, that was an issue. Duplicate provider, duplicate provider, that's it, done. So that was gone. Play screen, Terraform init. So the way I teach, I'll show you the errors and I'll show you how to fix the errors. So that when you go to the interview, you talk about the error and how you fix it. They see you as a genius and they hire you. You can say, hey, I was trying something that I had a duplicate provider error. Like, what is it about? Then how you fixed it, boom, they give you the job. That's how you get an interview. Clear screen. Now, what's the next thing? Terraform format. Format my code. Oh, load balancer got formatted, right? You got arranged. So it's good. Next thing, I want to validate. Terraform validates. Let's see if it's validated. Nice. It's validated. Now, Terraform plan will use my access key and secret access key and go connect to my account and try to see if it's able to create these resources. Terraform plan is the first time in which the access keys that I have stored here will try to make connection to AWS. This whole time, it needs to just downloading the software to the provider to my laptop, format the code, validate if my code is correct, syntax-wise, commas, the double quotes, everything is correct, is validated, is good. Then Terraform plan now actually takes my secret key and tries to connect to AWS to see if you can create the resources. And that's it. 16 resources can be created. Now I can go run a Terraform apply. You can see here, it will create what? First things, Terraform creates the most, the one you see down here is the first thing that creates. So this is the, hold on, sorry. Sorry. I just mistakenly hit paste somewhere. Terraform creates the first thing down. So you see VPC down here, that was the first thing that will create. After VPC creates, what creates next? The public subnet creates. Then a public, sorry, what's that? Public subnet number 2 creates. Public subnet number 1 creates. Then the security group creates. Then a last load balancer security creates. Then the route table creates. Then the route table association happens. Then the route table, creates at the same time. Then the load balancer attachment occurs to the target group. Then target group attachment to both instances. Look at that, stickiness, sticky sessions. That stickiness, right? It's a non-default parameter. So it's gonna be, if you're gonna enable it, you hit enable true, it will show after it's done creation. That's a health check. That's done. Load balance target group creates. And then the last thing, after all this, the last thing is what? The EC2 instance. The last thing that creates. That's it. The instance 1, instance 2. Okay. So 16 resources will be created. Let's go ahead and launch. So the plan is just a plan to see, hey, this is what I'm going to go do. But when it goes to go do it, something can go wrong. So Terraform apply. And this is where the stress begins. On the job, when you hit apply, you just pray to God that this thing works. Creating a VPC. That's it. You sit back, relax, you get paid $150,000 a year. That's it. It's easy, right, Isabel? It's easy, right? It's very, very easy. Right? Isabel, what do you think? It's easy, right? I think it's easy.
It's not easier through the AWS console.
Yeah, you can be in Japan running this stuff, just relaxing you. Kwasi thinks it's easy. Kwasi, what did you do now? Why is your code why your code failed?
I mean, it's just a little bit confusing. If you're not careful, you just have to make sure
You,
that
you show me. I already fixed it.
What was the issue?
With provider.
You had duplicate provider?
Yeah, because I add provider also. So I was not understanding why you
Okay. Yeah. You can put it in the main.tf, or if you want to remove it and have a different file. I prefer it be in the main.tf because having multiple files is just a headache. If something fails, you need to look at multiple files. The less things, the better in life, you know? And that's it, guys. It's creating. Everything is going to take some time because it's take load balance. You're going to register, create. You're going to have server 1, server 2. I think my instances are going to fail. I'm not sure because I have this issue with billing issue with my quota for EC2 instances. I think it's going to fail, but I'm not sure. But, you know, we'll see. But yeah, that's it, guys. That is it. We finished just in time. If I type the code, I guarantee you I'd have made an error too. I'm not perfect. So I just copied and pasted it.
Yeah, my mine was not able to create the EC2. I don't know
That's what I
what's
was
wrong.
saying. If you have to type, you have to be careful.
Yeah, that's why the best time to write Terraform code is you wake up in the morning, you drink your coffee, you're typing. After 3 p.m., don't try to write no code. Just 3 p.m., go for a walk. If you walk in the office, if not, go to the gym, go work out, After 3 p.m., I don't write no code. I don't do no work that I need to use my brain. No, no, no. We stop work at 3 p.m. Trust me. We really work from 9 to 3. After that, but yeah, that's it, guys. Even if it fails, well, we know the steps, right? It might fail because we don't have enough EC2 quota. I haven't paid my bill. That's what I think. I haven't paid my bill. That's what I think. Yeah, you all allows you one instance if you haven't paid your bill. So that might be the issue.
You
Yeah.
know why I like Terraform? If
I
because
what
sometimes
was that? What do you say?
when I say I like Terraform because when you want to delete your stuff, you don't have to looking for everything you created. You can just do Terraform destroy it.
And it destroys everything, right? So it's called a stack deployment. You can deploy everything at once, and you can destroy everything at once. You see that? There's no errors, there's no mistake and everything like that. So boom. EC2 instance failed because VPC limit exceeded. Yes, like I said, I don't have the capacity to create more than one EC2. It allows me one, so that's why it failed. So but yeah, I'm gonna go ahead and pay my bill tomorrow. I think I call AWS because they overcharged me for something. I think they overcharged me for elastic IP address, something like that. They charged me like $240. So what I did was I changed my debit card on there so they're unable to charge me. So I'm gonna talk to the AWS tomorrow. They might give me a credit, I have some folks who work there. But yeah, that's the error. So, but other than that, it works. As you can see, Amazon Linux 2 does exist within the console, so it didn't fail, but it failed because of our billing issue. That's why it failed, right? So Web 1 was able to create. If I stop sharing here and go to my console, and I'll share on this side, and we're done, right? We have 4 minutes left. We're done. Thank you guys so much for being patient with this. It's not easy. If I go to my EC2 instance, you'll see Web 1 is there. That's Web Server 1, right? If I go open Web Server 1 and take the public DNS name and I put it here, you should see, come on, is it gonna come up or still taking a while? Or maybe the load balancer name. Let's see here, load balancer did create as load balancer. And it looks like it's a classic load balancer actually. This is the DNS name for the load balancer. Open that up, and it should push me to server 1 or yeah. There you go. Boom. Hello from instance 1, right? There you go. I'm gonna put it in the chat so you guys can try it. So if I was able to create instance 2, then when you refresh it, it will send you to instance 2. Okay. So once I fix this issue, we're gonna run it again. But I'm gonna save my code. I'm gonna save the code on this server, on this Windows laptop. I'm gonna save it there. So I'm gonna advise you guys, watch this video, run this code. If you don't have any billing issues like I do, you should be able to see instance 2. If you refresh the load balancer again, you'll see hello from instance 1. Refresh it, you see from instance 2. Keep refreshing it, copy it, take it, use an incognito browser, um, and then run it there, and you should see instance 2. Okay? So because if you keep running the same browser, it will stick your session. You will stick your session since sticky sensor is enabled. You will keep seeing the same server over and over. Okay? And with that said, that's it. We are done. Any questions before call the night? Trust me, guys. Trust me. You have seen the jobs out there, right? All right, guys. I'm gonna stop recording now.